Hi, thank you for coming and welcome. Today we'll be talking about Pyampute. Thank you for the introduction. And if you're wondering what Ampute or amputation is, we'll get to that in a moment. But first, my name is Davina. I'm a PhD candidate at UCLA in the computer science department. I've worked on Pyampute with Rihanna Schuten and Prabhan Singh of the Eindhoven University of Technology. And today we'll primarily be talking about missing data. So first, we'll be giving motivation and context to Pyampute, what it does at a high level, and what problem it attempts to address. Next, we'll go over some background about missing data. Then we'll describe how Pyampute works under the hood, and then we'll follow it with some takeaways and future work. So why make Pyampute? Well, first let's dive a little more into what Pyampute is. So Pyampute executes a multivariate amputation. And so what that means is that we'll be masking data or removing data and therefore introducing missingness. And we do that on a complete data set. So let me see if I can see my laser over here. I cannot. Okay, so if you see on the left there, we have some complete data set, and then we quote unquote ampute, which is kind of a play on words of amputate and impute. And that removes data or masks data. Now we have an incomplete data set. So the inverse operation would be to impute, or taking an incomplete data set and then estimating the missing values to then get a complete data set. So hopefully this raises some questions. Some important ones are, what's wrong with you? Why would you get rid of perfectly good, precious, usable, complete data? Well, I promised you today would be about missing data, and it all comes down to that. So first, let's dive a little bit into missing data. Why do we care about it, and what's the big deal? Well, the problem with missing data is that it introduces uncertainty in some downstream tasks, such as statistical analysis, any predictive model you may use. And so I said the word uncertainty, but what is uncertainty? Why do we not like uncertainty? Well, there's a few frameworks to think about uncertainty. One is through the lens of logic and probability. And logic and probability says that uncertainty is caused by things that are unknown. So you have epistemic uncertainty, which says, you don't have enough data, or you're not confident enough, so therefore you don't know. Or there's aleatoric uncertainty, which means that it's just simply unknowable because it's due to a random process. The other way to look at uncertainty is through the lens of statistics, which says that uncertainty is related to error. So you have statistical uncertainty, which says, okay, you have a lot of variation, you are less precise. And then you have systematic uncertainty, which means you have bias. You are systematically inaccurate. And either way we slice the cake, lacking in confidence or having error in any analysis you want to do is an undesirable outcome. And so you may be asking yourself, well, Davina, how does this affect me? Well, can I get a raise of hands of anyone that's ever worked with an incomplete data set with missing values? Okay, that's a decent number of hands. And that's right, data everywhere is messy, and part of that chaos is missing data. And so we want to know, how does missing data affect our analyses? So let's go through a sample workflow for, let's say, you get a project. Well, first, you may get a data set. Yes, usually a huge hurdle to get over. And then you do some exploratory data analysis. You want to understand your data set before you do anything on it. And you find that there's missing data because you're using a real-world data set and the real world is not perfect. So then you want to do some data wrangling. You want to make it usable for your task. And you find out that your model doesn't accept missing values. It doesn't accept nada numbers or nans. And you Google on Medium, what do I do about my missing values? People don't really talk about this. And your Medium article says, oh, just drop your samples that are missing values, or, okay, just do like some simple imputation or estimating the missing value process. So you say, okay, that's easy. I'm going to slap a scikit-learn, whatever I like from there. And then I run my pipeline. And I get some results. And then I sit and I think, how do I know my results are reliable? How do I know they're robust, given that I just manipulated this data set? Isn't there meaning in the missingness that's occurring in it? So you're asking me again, Davina, you just told me this problem is everywhere. Why would I want to get rid of data if I don't already have that problem, if I have a complete data set? Well, the answer to that is that we want to know how missingness affects our analyses, and we can do that through controlled experiments. So for example, let's say we want to understand how imputation model performs. So we first get a complete data set. Let's say you simulate a data set, you sample from a distribution, or you get a real data set and you filter it down to the fully observed subset. Then you can impute or introduce missingness in a controlled way. So once you impute or estimate those missing values, you can then analyze the results and then characterize the behavior. So what does it mean to ampute in a controlled manner? To understand that, we need to ask the question, what causes missing data? And in the literature, we've come up with 3 missingness mechanisms, or the reasons for why data is missing, or data are missing. So the first is missing completely at random, which says that a feature or variable is missing that's not related to any other observed or unobserved features or variables. So for example, you have equipment that malfunctions for a day. And what this looks like is that there's no systematic difference between those samples that are missing values and those that are not, because the ones that are missing values purely to a random process. Second is missing at random, which says that the missingness for a variable is related to or related to or affected by some other observed variable. So for example, you have a patient intake form, you ask the patient's age, and you ask their alcohol usage. Let's say we're here in the US, where the legal drinking age is 21. You may find that the observed age of those that said they are under 21 will not fill out their alcohol usage, which means that the observed variable explains why there's an incomplete or partially observed variable. And lastly is missing not at random, which says that a value or variable is missing because of either the value itself or some other unobserved or latent feature or variable. And so an example here for that first case is, let's say you have equipment that doesn't register values over 100. Because the value itself is too high, it will be missing. In the second scenario, let's say you have a patient and they refuse testing due to religious reasons, but you haven't recorded their religion. So you have this latent feature, the religion, which would explain why you don't have any lab results for that patient, for example. And lastly and importantly, if you're given a data set post hoc and you don't know how it's generated and you want to ask, what are the mechanisms occurring in this data set? The only known tests we have right now are to test for missing completely at random and missing completely at random only. And we can't tell the difference if it's missing completely at random for some samples and missing not at random for some samples or only for certain features. We can only test for, is there missing completely at random in this entire data set? And so now that we understand a little bit about missingness mechanisms, hopefully by now I've convinced you that A, missing data is a problem, and it exists in a lot of domains with real-world data sets. And B, it's not that illogical to ampute or mask data in order to actually understand how the missingness will affect our analyses. And hopefully I can now convince you that we can use Pyampute to do so, following certain missingness mechanisms. So what ingredients go into concocting missing data? Well, one is the missingness mechanism, but we also want to know how much data do we want to be missing? And what features do we want to be missing? And what features do we want to influence the missingness of our incomplete features? And in the real world, I just gave the missing completely at a random example. It's not just one kind of missingness occurring in your data set. There's so many processes that are going on. So Pyampute actually allows you to specify any number of patterns to reflect this. So how does Pyampute actually achieve missingness accounting for all these components? Let's take a look a little under the hood. So first we take a complete data set. You have n samples, m as in mother features, and we have some user-defined patterns of missingness that isn't depicted here. And so first, we'll assign samples to each pattern according to a desired relative frequency to other patterns. So I want pattern 1 to occur 30% of the time and pattern 2 to occur 70% of the time. And then each sample in that pattern will be assigned a score that's going to influence its probability to be missing. So the scores are calculated by computing the dot product with a set of user-specified weights for each feature. And these weights determine the size of effect of that feature for the probability of missingness. Then we take these weighted sum scores and we convert them to a probability to be missing using a function. So for example, a sigmoid function. And then we assign an indicator to be missing for each sample and each of these pattern candidates groups by using the binomial distribution with the probability and one trial. Then we apply the mask according to the indicators and the desired features you want to be incomplete under that pattern. So now that we have an idea of how Pyampute works under the hood, what would I actually use this for? That is, I said, oh yeah, we want to understand how missingness affects our analyses, so we want to characterize performance. But what does that look like? What does Pyampute actually buy us? So here are some ideas and examples of use cases. So we can, analyze the bias. How do different missingness scenarios and imputation algorithms affect the bias of the resulting data set? Or let's say we want to look at how the different missingness scenarios and imputation methods affect downstream performance. Or we can look at imputation of performance. Which imputation methods are most accurate under the different missingness scenarios? And you can simply also just stress test your model. How robust is your model to certain subpopulations missing data? And so we're going to dive into a demo that you would use of how you would use Pyampute for the simple case of looking at the bias. How would we evaluate bias? So we have a demo here. And if I do this properly, I don't know how to change. Let's do it like this. I cannot see my mouse. All right, this is much better. All right, so hopefully you can see this. Sorry for these errors. Let's make this a little bigger. Please let me know if you cannot see or read the text. It looks a little small. Let's make this bigger. Okay. So first, we're going to create some fake data. We're going to create a generated data set. We're going to sample from a multivariate normal distribution. And then we're going to see how the different missingness mechanisms and the amount of missingness will affect the bias in our data set. And we're going to use two very simple, naive ways of dealing with missingness. And we can compute the bias since we know the true means. We are simulating this data set. So first, we create some generated data. I ran this ahead of time, so we don't have to wait for it. So we have 3 features and 1,000 samples. These are the means for the 3 features, the 10, 5, and 10. Then we have a correlation of 0.5 for each of the variables to itself, and we create a covariance matrix, and then we sample from the multivariate normal distribution and get this complete data set here. So before I demonstrate Pyampute itself, we're going to need some convenience tools or additional helper tools. So one is we need something to deal with the missing values. And so something to transform the nans or not on numbers. And so in this demonstration, we'll just look at row-wise deletion and iterative imputation. So you have this scikit-learn transformer here, and you can either ask it to drop or iteratively impute. And lastly, we have this bias scorer, and we can use it to score, like, against scikit, grid search, or the parameter grid. And we're just going to compute the bias based off of the true biases that we know. I mean, the means that we know. So here's a basic example. It's actually very easy to use Pyampute default. You don't even need to know the API. You can just pass it, create a basic multivariate amputation object with just a seed. And by default, this will give you one pattern of missingness with a missing at random mechanism, where half of the rows will be missing sample values, and half of the features or variables will be incomplete. And by default also, that means the remaining half of the features will be used to influence the missingness of those incomplete variables. And so it's really simple as creating the object and calling fit transform. And we can see that, yeah, we have some nans here. So we have indeed introduced missingness. And in Pyampute, we can actually visualize the missingness in our data set. So we have this empty patterns class, and you can call get patterns. And here we can see the missingness. So it looks like this is out of order, but what happened is it randomly select half, which half of 3 is 1.5, rounded down to 1. It randomly select the 0th feature, and it groups all the missing features together at the end, which is why it's out of order here. And we can see that about half of the 1,509 rows are missing values. And we can't see what's the mechanism. We know it's missing at random, but in general, you can't test for it, you can't see it visually. If you want a custom pattern or multiple custom patterns, we need to enumerate a few things. We need to know how much missing data do I want in the data set overall. And then for each pattern, I need to know what variables do I want to be incomplete. There is no default for this, you must specify. And then we have defaults for the rest of these, but we also want a list of weights. So what's the size of effect of each feature onto the probability of missingness? Which missingness mechanism you'd require? What's the relative occurrence of a single pattern against the others if you have multiple patterns? And a function to convert the weighted sum score to a probability. And by default, we'll select a sigmoid. So here's an example of a custom pattern. We request that 30% of the data set be missing. And our pattern is we want feature 1 to be missing. And we specify the weights such that feature 0 and feature 2 will influence the missingness of feature 1, making it a missing at random scenario. And then feature 2 positively affects it, while feature 0 positively affects it, while feature 2 negatively affects it. And then we request sigmoid left. So this is actually the inverse of a normal sigmoid, where instead of a high score meaning a high probability, a low score means a high probability of being missing. And then we can visualize the missingness here again. So we saw that overall 30% of the data set is missing. We requested that feature 1 be missing. And again, we can't visualize all the other information that we know that we requested for. And if you wanted to specify more patterns, the only difference here is you just add another dictionary to this patterns list. And I've added this frequency, so oops. We can see that I requested that 30% of the 30% of samples missing be from pattern 1, and the 70% of the 30 samples missing be from pattern 2. And then on top of that, we can actually now use scikit-learn grid search. So I can now comprehensively try a bunch of different amounts of missingness, a bunch of different patterns. I can ask for all these different types of imputation methods, and all I have to do is make a pipeline of the amputation, and then whatever data manipulations methods I do after that, and just run fit. And I get this whole grid search result where I can look at the mean test score here was from the bias scorer. So we can see bias here and the kind of spread across when you use a drop for dropping row-wise samples with missing values, or if you do iterative imputation. I mean, you can slice this all sorts of ways, but this is a simple example. And last, you can also do repeated experiments by just using the same grid. With however number of times, you can set however you want, number of repetitions, you get the results, and then I can now get confidence intervals on my bias for these different groups. And you can slice it however many ways you want, but now it's really easy. All I have to do is, okay, param grid, run, fit, train, whatever. So hopefully, now that we've gotten a taste of Pyampute, and if this goes full screen for me, which it doesn't want to, let's do some takeaways. So I'll try to do this really quick. To our knowledge, this is the first multivariate amputation procedure where you can introduce missingness jointly. Previously, most methods just say, oh, it's like at random, and I'm going to do feature 1 on its own, feature 4 on its own. Now you can actually do it in a more sophisticated way. And because we use scikit-learn, it's just so easy to incorporate this into a larger pipeline for any experiments you might be doing. And because you have this grid search, you can then do systematic evaluation and really understand under all these different scenarios, what are your results? And so moving forward, we want to know, when do we want to split the data? Do you split before you ampute, which like in the real world, you would get an incomplete data set, and then you split, you split it, and then you train an imputer. Or do you do it after amputation? Because we calculate the weighted sum scores using all the other samples in the candidate, so there's potential for leakage. Second, we want to expand this into the longitudinal domain, where we can ampute longitudinal data sets. So thank you so much. Please use this package if you have any interest and give us any ideas. And before I take any questions, I want to give a huge shout out to Rihanna Schutten, who developed the original methodology of multivariate amputation and implemented it in the mice package in R as the ampute function. This project would not exist without her. And thank you so much, and I'll be taking any questions.
Thank you for that wonderful talk. You were so smooth. Nice transition here. Okay, so we have lots of questions. I'm going to try to get to them, but if not, if you can answer maybe in the chat of the Zlotnick Ballroom. Okay, so our first question, I'm guessing, is your package name so gruesome because of Ampute, the original method name?
Yes, it's like a play on amputing like a limb and impute.
I like it.
Yeah.
Okay. Yeah. Are you going to come up with a good logo for that too?
Yeah, actually, I'm taking any ideas. If you have any ideas, maybe involving a knife. I don't know if that's too violent, but
maybe a good bandage,
yeah.
Okay, so our first question is, great talk. I found your statement, the only known test for mechanisms can only test for MCAR.
Yep.
Really curious, can you speak more about this? Is there a fundamental limitation here? I would imagine something simple like logistic regression of missingness on features would be one approach to search for dependency.
Okay, I cannot speak to all the components of this comment. Really good question. I'm happy to message you later, Zachary. Yes, it is a limitation, and currently, missingness is kind of like the stepchild, the unloved stepchild of data science. And while we have this kind of framework paradigm of these mechanisms, and it came out in like the 70s or something like that. A lot of work recently, like Judea Pearl, who's doing a lot of causality stuff on missingness. We're becoming more and more aware that maybe these mechanisms aren't as useful as we think they are, but we have to work with what we have. So I do think there might be a fundamental limitation based on this paradigm. And hopefully the more we pay attention to missingness, the better we can scope out and flesh out this area.
Would you describe it as an unloved stepchild or just actually a missing stepchild?
Both.
Okay, so our next question is from Alan Harvey. Have you used Pyampute to create or augment data sets that are then used to train a machine learning classifier?
I've started to. I'm using this in my own thesis work. I think it's very useful. And I found my thesis on imputation. And so this makes it pretty easy to now just select my amputation method and go. And a really important point is, we talked about maybe this paradigm isn't super robust, but you think of missing not at random, and it's actually not very specific. There's like a million ways you can come up with a missing not at random situation. And so I'm actually using this in my research to try to capture a bunch of different missing not at random scenarios so we can have a little bit better idea. I feel like I've covered a decent area in here, and hopefully my thesis passes.
The most ominous. Okay, so have you ever considered using Ampute for anonymization?
No, that's very interesting though.
Okay, so I'm going to try to just go to the next one because I want to make sure we can get as many as we can. So let's say we want to analyze our model performance on missing data without knowing what type of missingness occurs in our current data set. How do we decide what kind of pattern we should introduce to replicate the missingness?
All of them. You have to try all of them. If you don't know what's created in it, for now, the best I can think of is you filter down to the fully observed subset, which is what I'm currently doing. And yes, that will bias your data set, but we're working with what we got. And then you try a bunch of different mechanisms. And an interesting idea I thought about, or as I was working with my colleagues on my imputation work, is it may be possible, but also way too large search space, to try a ton of different patterns and see how close you can get to the original missingness profile. And in that way, you might be able to unearth the original missingness mechanisms. But that's more of like a food for thought.
Okay, thank you. Then we have another question from Matthew Petrov, who said, can you please comment on the difference between the techniques you're using and jackknife-based null tests?
I'm unfamiliar, unfortunately, but I will definitely educate myself and get back to you.
Okay, thank you so much for your generosity on the Q&A as well. And I'm sure our speaker will be happy to answer more questions. You already have some suggestions for logos in the chat, so.
Thank you.
Yeah. Okay, thanks everyone. Let's thank our speaker.